Welcome back. Number 61. I'm going to try to do these faster and with maybe a little bit more enthusiasm if I can possibly drum some up. I do love geometry, but I have been doing it all day today, and I want to try to make this exciting for you. I try, and it's not always successful, but hopefully you are with me here for number 61. Two circles are graphed. Circle A has a center at 1, -5 and a radius of 2. Circle B has a center at 5, 2, and a radius of 5. Mackenzie is trying to prove two circles are similar. What steps does she need to take in order to show circle A is similar to circle B? First of all circles are similar. Two figures are similar if there is a set of transformations that will move one figure exactly over to the other figure, and then a dilation that can make that original figure match up with the new figure, pre-image versus image. So all we have to do here is show the transformation to move the center of circle O over to the center of circle B. I said O, didn't I? From circle A over to circle B, and then what dilation it would take to map the pre-image onto the image. So if we look at our centers, here's what you want to do for your notation. You want to say, if our center is at XY, to go from A to B, remember your X is your left and right. You go to the right 1, 2, 3, 4 spaces. So we would say X plus 4 if we're going to the right 4. And then the Y would go from, so we landed here, we would go up 1, 2, 3, 4, 5, 6, 7 spaces. So that would be Y plus 7. Another way to figure that out is look at your original center for your A is 1, -5. The 1 is your X. For your B, the 5 is your X. To go from 1 to 5 on a number line, you are adding 4. So that would be your X plus 4. You don't have to have a picture. To go from -5 to 2 on a number line, from -5 to 0 is 5, plus 2 more would be 7. So that would be your Y plus 7. So you could do it that way. Then to find what dilation it would take, so this is the translation that would map the center for A to the center for B. The dilation, remember, for a dilation or a scale factor, you always want to put the image over the pre-image. So in this case, we're going to put the image radius, and I'll put R for radius, over the pre-image. This is so messy, I apologize. Radius. And so our image radius is 5 and our pre-image radius is 2. So circle A would have to increase the scale factor of 5 halves in order to map on to B exactly. Okay, so you want to first figure out the translation to get the center to match up or to correspond. And so you go right 4, up 7. And then
Mr. Frazier, please come to Mr. Allen's office immediately. Mrs. Frano and Mr. Frazier, please come to Ms. Allen's office immediately. Thank you.
Again, I apologize for the interruptions. I am at school. Then for the dilation, you always want to put the image over the pre-image, and in this case, for circles, you use the radius for each one. Now, you're going to be using this on these next few questions, so be ready, and I'm going to try to go faster because I don't want us to be here forever for this video. So show that circle C with center -1, 2 and radius 3 is similar to circle D with center 3, 4. So you're going to do the same thing. This time we don't have a picture. So we're going to ask ourselves, first, here's our, I'm going to squeeze it in up here, okay? So our original XY, that will be our original center for circle C. What would I have to do to go from C to D? So to go from -1 to 3 on a number line, from -1 to 0 is 1, and then plus 3 more. So that's 4. So I'm going to add 4 to my X. And for my Y, I'm going from 2 to a 4. So I'm going to add 2 to my Y. So Y plus 2. Again, you can watch this back, slow it down, pause it, whatever you need to do, but I'm going to keep going. Then for your scale factor or your dilation, you take your image radius 5 over your pre-image radius 3. So it would be an enlargement, enlarged by 5/3. Remember, when that number, whether it's a fraction or a whole number, is bigger than 1, so 3/3, if it's bigger than 3/3, then it's going to be an enlargement. If it's less than that, it will be a reduction. Okay? Either way, dilation. Show the circle C with center 0, 2 and radius 6 is similar to circle D with center 0, -6 and radius 2. So you do the exact same thing. So we're going from 0 to 0, so there is no change in our x. So we take our original xy. There is no change for your x, so it just remains x. You go from 2 to -6 in your for your y. So we're going from 2 this time. So we're going left 2 to the 0 and then 6 more to the left, 8. You can graph this and count if you would prefer, but this translation would be x, comma, y minus 8. And then again, for your scale factor, you take your image over your pre-image. So 2, radius of 2 over radius of 6. So that will be a reduction of 1/3. And that's your scale factor, or your dilation at a scale factor of 1/3, 1 to 3. Okay? This next one you have a little work to do before you can skip right over to that. This says show the two given circles are similar by stating the necessary transformations. So the first thing you need to do here, because on these other problems we already had the center and the radius, is figure out the center and the radius. So we did this not long ago. We learned the equation for a circle is x minus h all squared plus y minus k all squared equals r squared. Easy part here is to figure out the r for each one of these, because this is 3 squared would give you 9, and this would be 4 squared would give you 16. So we already know the radii. The radius for this one is 3, and the radius for this circle is 4. For circle D is 4. Now, to figure out the centers. So the center is always going to be your HK, but notice there's a plus here. So that means this will be x minus a -3 all squared, if you remember that, plus, and then this stays y minus 2. And then this will be, we'll just do them both at the same time, same and same. I guess I didn't need to rewrite that one, but that's okay. So the center here would be -3, 2, -3, 2, and the center for circle D would be +1, +5. Now you have what you had in 62 and 63. You can figure out what the transformation is. So the first thing you would do is go from, here's circle C, from C to D. And here's circle D. So that means C is your pre-image, D is your new image. So from -3 to +1. So here's our notation. XY translates to. We're going to take our x and we're going to add to that 4, because we're going right 4. Excuse me, I didn't mean to put that parentheses there. A comma. From -3 to 0 is 3, and then plus 1 more will be 4. Then for your y, we're going from 2 to 5, so we're going up 3. Again, you're more than welcome to graph these so that you can visualize them. Then for your dilation or your scale factor, in this case it will be an enlargement. You will put your new image over your original pre-image, so it's an enlargement of 4/3. Great. 65. The circle shown below is centered as the origin. It has a center as the origin and the point -4 to -2. Which of the following is closest to the diameter? Now, Here's how we did this. What we're trying to do is figure out this length all the way across, right? But first, what we do know is this is 0, 0. You can do this a couple different ways. You know, this point is -4, -2. You can use the distance formula, and you also can use Pythagorean theorem, which is a form of the distance formula. The distance formula is a derivation of the Pythagorean theorem, and here's how we did this in class. So this is at -4 and -2, so that means this from here to here is 4. From here to here is 2. So we have the two legs of our right triangle, and we're missing the hypotenuse, the C. So that's how I would say to do it. It makes it so simple. 4 squared plus 2 squared equals C squared. Then you get 16 plus 4 equals our C squared. 20 equals C squared. Take the square root, and that, remember now, is the radius. So be careful, don't stop there. C, and it might even help if you call this, instead of C, you call this R, so that when you have solved this, you know, oh, wait, I've got R. I need the diameter. Always go back and look at what you're looking for. Okay, so we're looking for the diameter, so that means you take 4.47 and you times 2, because remember, the radius times 2 gives you the diameter. And so the diameter would equal 8.94. C. Again, play that back if you need to see it again. 66, I'm going to do this the most simple way. Lines AC and AB are tangent to circle O. What that tells us is, remember we learned this, if you have a radius that comes down to the point of tangency, you have right angles here and here. You remember that? And if you have that, then these two angles here and here, angle CAB and angle, I don't know what that letter is, that's an O, okay. COB are supplementary angles, which means it says if measure angle COB is 134, what is the measure angle CAB? You just subtract 180 minus 134, since they are supplementary angles, and that gives you 46 degrees. So that is A. Another way to find that is to find these arc measures. You still get 46 degrees. I'm not sure how the book does it, but hopefully they do it a different way. Or not the book, excuse me, the website, Escambia County's website. It would be nice if you had a different perspective. But if you can remember that, that is perfect. 67, find the perimeter of triangle ABC given the distances. RA is 12, AB is 16, and QC is 8. This one is, this problem is based on a theorem that says when you have tangents from the same point on the outside of a circle, that is, well, this circle is inscribed within this triangle, so it pertains to that, but you have equal distance from that point outside of the circle to the point of tangency on either side here. So that's 12, this is 12. That's 8, this is 8. This whole thing is 16. This little piece is 4, because 16 minus 12 is 4. And so this little piece is also 4. So all the way around, these, from the point outside the circle to the point of tangency, will always be congruent. Here, 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 and here, and here, and here. And just go back and make sure you look at what they're asking for. They want the perimeter. So you're going to add up all of those sides. This one is 16. This one is 12. And this side is 20. So you add those 20, 16, and 12 together to get your perimeter of 48 centimeters. Great. Moving right along here, 68. We are looking for, we're looking to fill in this paragraph proof. Quadrilateral ABCD is inscribed in circle E as shown below. Complete the following proof to show that that angle ABC and angle ADC are supplementary. So we know that they are. We learned a theorem about that. This is the proof of that theorem. First, it says that the measure of arc ABC plus the measure of arc ADC is 360. That makes up the whole entire circle. The whole entire circle is 360. So like if you go from A through B to C, and then from A through D to C, you get the whole entire circle 360 degrees, since these two arcs make a full circle. Next, 2 times the measure of angle ABC is equal to the measure of arc ADC, and 2 times the measure of angle ADC is equal to the measure of arc ABC. And here's why. If you recall back when we were talking about inscribed angles and the measures of their intercepted arcs, an inscribed angle ABC is half the measure of its intercepted arc. And so this says that 2 times the measure of angle ABC is equal to arc ADC, and vice versa with the other one. And the reason for that is there's no simple way to put this, but the measure of an inscribed angle, I'm going to kind of shorten it, is half the measure of its intercepted arc. So there's no easy way to say that. It's just that the measure of an inscribed angle is half of the measure of its intercepted arc. Then on the next step, it says, by what can you say 2 times the measure of angle ABC plus 2 times the measure of angle ADC is 360? Well, here's what. 2 times the measure of angle ABC is equal to ADC. So you can substitute. Remember, whenever you put something in for something else that equals, it is substitution. So the measure of arc ABC is equal to 2 times the measure of angle ADC. So that is by substitution. Okay. Divide by 2 to get the measure of angle ABC plus measure of angle ADC equals 180, and therefore those two angles are supplementary. 69, find the area of a sector with an arc length of 40 centimeters and a radius of 12. So we have to find the area of a sector. We have the arc length. So we're going to start with the arc length. The arc length is equal to, here actually, let me draw this. I have a circle, a little messy, that's okay. We are ultimately looking for the area of the sector in here. Remember, that's like a piece of pie or a piece of pizza, area of a sector. We have the length of this arc out here is 40 centimeters. If you were to measure that with a string, it would be 40 centimeters. We have the radius of 12, and we need to find this angle measure in here. We'll call it X. We need to find that. So in order to find that, let's use the arc length. So to find the arc length, it is angle X over 360 times the circumference of the circle, d pi or 2 pi r, either one. And that is going to equal arc length. Okay, so here's what it says. We're looking for X. We need that for area of the sector. And 2 times pi times the radius, we have 12, is equal to, and we have the arc length of 40. So we have everything but the angle measure. So I would just say plug all of this into the calculator. 2 times pi times 12, 24 pi. And since this answer is not in terms of pi, just go ahead and multiply that and say 24 times pi button. Actually, here's what I did, sorry. I went ahead and said 24 pi. I said X times 24 pi. I went ahead and multiplied both sides by 360. You don't have to do it this way. You can just do it all in your calculator from the get-go. Then divided both sides by 24 pi. And I did use the pi button, and I got approximately equal to 191.0 whenever you round, so it's awesome. So you can just say 191 degrees is X. So X is 191 degrees. Now you use that in the area of a sector formula, which is, let's do it over here, X over 360 times this time the area of the circle, pi r squared, that equals area of a sector. Go back, look over your stuff that we've done for this. This wasn't that long ago, and study. So 191 over 360 times pi times radius squared, 12 squared. And that's going to give me the area of the sector. So you just multiply this out, 191 times 144 times pi divided by 360. And that'll give you 240 square centimeters. Good. Two more. Allison created an embroidery design of a stylized star emblem. The perimeter of the design is made by alternating semicircle and quarter circle arcs. Each arc is formed from a circle with 2.5-inch diameter. We have that here, which means that our radius will be, that's 2.5, so our radius will be 1.25 for each one of these. So here's what I'm figuring. There are 4 semicircles. How many circles is that? 2 circles. A semicircle is a half circle. So that's 2 circles. 4 quarter circles. How many circles is that? 4 quarters makes $1, so that's 1 circle. So we have a total of 3 circles, and we're looking for the perimeter of her design. What is the perimeter of a circle called? Not really giving you time to answer it. It is called the circumference. I can't spell and talk at the same time, circumference of the circle. So that's going to be 2 pi r, or pi times diameter. Diameter times pi. That's the circumference of a circle. So we have 3 of them times d pi. So 2.5 pi. None of these are in terms of pi, so you just multiply it out using your pi button. 23.56. And they went ahead and rounded to the nearest whole inch. Last one. Volume of a triangular pyramid is 1/3 area of the base times the height. This is capital B is area of the base. I want you to look. This is a right triangle. That's what this little symbol is here. That's your base. So to figure the area of your base, area of a triangle is 1/2 base times height. And that little b means the area of the base of the triangle. Remember, this is, since it's a right triangle, you can do 6 and 8 or 8 and 6. It doesn't matter because multiplication is commutative, so it doesn't matter which one you do. And I meant to put 6 and 8, not 6 and H. I was thinking that was a B. Kind of looks like a B. Let's fix that. Okay, and then so half of 48 is 24. That's the area of my base. So 1/3 times, let's actually do this, let's use parentheses, 24 times the height. Look, they gave me the H height, that's what I need. 5, and then divide by 3, 40 cubic centimeters is the volume of my pyramid. Remember, for the EOC, you will have the volume formulas, they just won't tell you what they're used for, so just remember that 1/3 area of the base times the height is used for cones and pyramids. So remember that. All right, see you next time.